What's going on, everybody? Welcome to the machine learning with Python. Previously, we have discussed about pre-processing steps required in regression, or you can say that in any model. We have discussed how to fill the missing data, how to extract and get rid of the unnecessary features. We have also compared the data by plotting, and at the end, we splitted the data for training and testing. In this video, we'll learn about training, testing, and scene behind the regression. I've given the basic intro in the first video of this series, so if you haven't watched that video, go and check out. Now let's start. Okay, first import Numpy as np, import matplotlib.pyplot as plt. Okay, now let's make a numpy array of 0 to 9, means length 10. So right here 0 to 9, and let's define a empty numpy array and say it y. Now let's say y is equal to x square. So write for I in range length x, which is 10 here, and append the x square in y array. So write y comma xi into xi. Now simply print the y. Here you can observe y array containing x square values. Now let's change the x square to 2x plus 3. And also let's draw a scatter plot. So write plt.scatter x comma y, and let's change the y limit 0 to 25 and say plt.show. That's it. Let's run the code. So here you can observe the scatter plot. It is linear, right? Now suppose you have only this plot and you don't have the equations. So if you want to find the equation, we'll find its intersection on y. So it is near to 3, right? Now to find a slope, we'll find a value of y at any point. So at 2, the value is near to 7. So 7 minus intersection, which is 3. So 7 minus 3, 4, divided by 2, x value. So we will get 2 value. So means our slope is 2 and intersection is 3. Now let's make a numpy array of nonlinear values. So write y is equal to np.array and write any 10 nonlinear values. Try to write in increasing order, because when we plot the regression line, it will be easy to understand. That's it. Now let's observe the scatter plot. So run the code. Here you can observe the nonlinear scatter plot. Now it will be difficult to find the equation of this plot. Now let's open this plot in a paint so we can understand better. Here we go. Here one thing we know for sure, that the equation of the line is y is equal to mx plus c, but we don't know the slope and the intercept value as of now. Now seeing the data, the best fit line can be like this, or it can be like this, or even it can be like this too. So how will we know what is the best fit line? So for that, first we need to find the slope value and the intercept value. So the slope can be calculated by mean x into mean y minus mean xy upon mean x into mean x minus mean x square, and the intercept can be calculated by mean y minus m into mean x. So the equation is y is equal to mx plus c. Now let's actually implement it in code. So let's say slope is equal to mean. Okay, we need to import the mean from statistics. So write import from statistics, import mean. So let's write slope is equal to mean x into y minus mean x into mean y. And let's keep this multiplication quantity in round bracket. Here 2. Oh, this is minus and mean x dot mean y is plus. Okay. Now divided by mean x into mean x, and let's also keep it in round bracket, minus mean x square. That's it. And intercept is equal to mean y minus slope into mean x. Let's keep it in round bracket too. And finally, our regression line is mx, means slope, into x plus c, which is intercept. Okay, now let's plot the regression line. So write here plt dot plot x and regression line. That's it. Let's run the code. So this is the best fitted line. Let's understand one more topic, which is squared error. So suppose the best fitted line which we have find using the slope and intercept is this, and the mean value of this point is a constant value. So suppose that constant value represent this line. So let's say it is mean and this line is fit line. Now these dots are an actual value of x and this fit represent the predicted value. So the error between actual and predicted is this. So to find a squared error, we will simply square it. Because error can be positive or negative also, and we want to get rid of the negative value. So why not we take absolute value instead? So in the case of outliner, the error will be big. And the square of that error will very big. Means we want to let the user know that this model, means the regression line, is not best fitted. And also the square of small error will be even smaller than that. Now let's write the equation of squared error. So it is squared equal to 1 minus squared error due to the fitted line divided by squared error due to this mean constant line. And let's keep it in round bracket. Means we want this minus quantity smaller, nearly equal to 0. So let's say AC fit is equal to 0. So this whole quantity will become 0 and 1 minus 0 will be 1. So this square term will be 1. Means if we get 1, our model is better, means far better than better. Now if the squared quantity is 0, means the term of the squared error should be 1. Means our mean line is equal to our fitted line. Means our model is very worst. So in the regression, our algorithm tries to make this squared error equal to 0. It is not possible to make it 0. It is only possible when our data is linear. So instead, we try to make it near to 0. More it is near to 0, more accuracy we will get. Let's start from where we left in previous video. So open the previous code. Let's get rid of this unnecessary part, this print x and print y2. Now we want to train our model. So first let's import a linear regression from Sklearn dot linear model. So it's linear regression. Keep in mind that it is a case sensitive. So let's define any variable. So CLF is equal to linear regression. And let's fit our model. So CLF dot fit X train and Y train. And to find an accuracy, write CLF dot score X test and Y test. So basically we are testing our trained model into a test data set, which is 15%, I think. And print accuracy. So let's run the code. So it will take too much time for training. Here we go. So the accuracy is around 91.41. Means our model is predicting 9 true values out of 10. Means it is very good accuracy. Here we can also try other regression algorithms. So instead of linear regression, import first from sklearn.svm support vector machine, import support vector regressor. Now change CLF to SVR. Now simply run the code. Okay, there is a typing error, so we forgot to write an. Now run again. Here we go. So you are getting accuracy around 69.39. Not bad, but worse than previous one. So the only way to choose a better algorithm for your dataset is to try more and more. More you try, more you will understand which model is better for your dataset. That's all for today. In the next video, we will learn about a classification and we'll try to cover one algorithm from classification. Thank you for watching this video. If you have any doubt, write it in comment section or email us. We will try our best to solve the problems.